Well, good morning or good afternoon, depending on where you're joining us from. Thank you for joining us today for the Harmful Algal Bloom webinar series. My name is Chad Cook, and I will be your moderator for today's webinar. I serve as the Associate Director of Outreach for the University of Wisconsin-Madison Division of Extension's Natural Resources Institute. The Algal Bloom Action Team is a collaboration of water professionals, researchers, and educators from 12 states in the north central region of the United States. Team members represent the National Network of Water Resources Research Institutes, the North Central Region Water Network, and University Extension within each state in the north central region. The Harmful Algal Bloom Action Team is the host or sponsors of today's webinar. So today we're going to hear a little bit about some of the public perceptions, expectations, and realities around harmful algal blooms, and also hear about a decade's worth of Lake Erie water quality monitoring data coming from GLERL and CIGLR. A couple of housekeeping items before we jump in, but we are using Zoom webinar today. So if you are having audio issues, you can connect via your phone. Just click the up arrow on the mute icon and select the switch to phone audio option. We'll be using the Q&A panel for our speakers today, and there'll be dedicated time after we get through our two presentations for questions and answers. The Q&A panel is found on the bottom of your screen, one of the icons and buttons you can click. Be sure to read other questions that attendees have put in already, and if you'd like, you can upvote those questions, and so we'll try to take those most popular questions first as we kind of go through the questions and answers at the backside of today. There's also a chat feature for Zoom. Use this feature if you're having technical difficulties, if you want to communicate with me or one of our other moderators directly, or if you have questions about the Algal Bloom Action Team. Don't use the chat feature for questions. Make sure that those go into the Q&A panel for our speakers. So we're going to get going today. We have two presenters. We've got Gina LaLiberte, who is the statewide Harmful Algal Bloom Coordinator for the Wisconsin Department of Natural Resources. Gina has over 30 years of experience in studying algae. And Anna Boegehold is an algal toxin and ecology research specialist with the Cooperative Institute for Great Lakes Research and works with their harmful algal bloom monitoring team. So, blew through this already. So here's just a little bit of the background on the Algal Bloom Action Team. Our website, if you'd like to learn more about that, it's northcentralwater.org/HABs. And we're going to kick off with Gina. Gina leads the response and communication of cyanobacterial blooms. There we go. Communication of cyanobacterial bloom issues for the state of Wisconsin. A lifelong resident of the Great Lakes region. She has a BS in biology and an MS in resource ecology management from the University of Michigan. And as I mentioned, she's studied algae for a long time. So Gina, I'm going to stop sharing and let you start sharing and kick off with your presentation.
There we go. How does that look?
Looks good.
Okay, I'm going to move my controls back over. All right, well, thank you, Chad, and thank you to the Algal Bloom Action Team for inviting me to speak today. Try to advance there. Yeah, so a large part of what I do for my job is, especially during bloom season, is communicating with the public. And it's always interesting to me to see what people's perceptions are of cyanobacterial blooms and their formation and where they occur. And these perceptions can be really important as they affect how people assess risk around cyanobacterial blooms and affects their behaviors and their decisions. So a lot of these perceptions that I'm talking about today, this isn't really a formal sociological assessment of these, but I am going to try to cover a number of things that I've seen come up repeatedly in my interactions with people. And I will also admit to finding it very useful to lurk on social media. So if there's an article about cyanobacterial blooms, seeing what people have to say on Facebook or Reddit. So I've been considering the public's perceptions and expectations about the blooms in my work in revising Wisconsin DNR's outreach materials around cyanobacterial blooms. And I hope that this can be useful to others who are doing similar sorts of things. So what causes blooms? We've been really good at hammering home this message that high nutrients plus heat from summer temperatures leads to blooms. And of course, this is true. You've got to have high nutrients to build biomass. Most cyanobacteria actually grow optimally at higher water temperatures than other types of algae, and this causes blooms. But this doesn't really encompass the entire possibility of drivers of cyanobacterial blooms. So when blooms do occur outside this particular equation, it can be very perplexing for the public. They see a bloom, they don't know, well, this lake has this characteristic, this is going on, why is this happening? So what does cause blooms? It's nutrients, but not always. Obviously, nutrients are going to support high biomass of cyanobacteria. And we've done a really good job of linking bloom occurrence to nutrient inputs in the public's mind. I've found that there tends to be this sort of belief or expectation that when you see a bloom, it's occurring because there's been some sort of nutrient input immediately preceding blooms. The truth is that there can be sometimes significant time lags from inputs, or even something that happened in a previous year, like a really large storm that brought a lot of sediment into a lake. Some of those things can be drivers as well. And of course, sort of the usual suspects of planktonic blooms tend to be adapted for high nutrients, but there are other bloom forming taxa that can prefer and are adapted to grow in low to moderate nutrient levels. And so this is addressed in this paper by Dr. Kate Reinl and others. I am going to put links to all of the things I cite and some other resources in the chat when I'm done with this talk. So yeah, there are some species that are adapted for growth in lower nutrient waters. And when people are on, say, for example, an oligotrophic lake, it can be really distressing for them to see a bloom growing in their lake, because they think, well, this lake has low nutrients. We've got a bloom now. It can be really distressing to them, and they think that something's happened to create a large nutrient input in the lake. They think that their lake's in trouble, or quite often they blame development that's going on in the watershed or agriculture in the watershed, which can, of course, be causes. Something that happens sometimes too is they blame the actions of a somewhat disliked neighbor as well. So yes, nutrients can drive blooms, but not always the cause. So going to talk now about a recent event that really hammered home for me how very strongly held this immediate input thought is in some people's minds. So we had a bloom on the Fox River in just north of Lake Winnebago earlier this year. So in this photo in the upper right, this is Lake Winnebago here, the north end of the lake. The Fox River flows from east to west. And here in the yellow circle, you see a lock and dam system. And this is a picture of that lock and dam. It's kept closed to prevent the movement of non-native round gobies through the Fox River channel into Lake Winnebago. And you can see there's a pretty significant bloom there. It's starting to decompose. It smelled really bad, and it was quite extensive. And what was happening is that we had this really large bloom in Lake Winnebago that was concentrated by wind at the north end of the lake, and then was traveling through the Fox River on north to Green Bay. And we got a number of complaints about this. What was really interesting is one person who reported this, I explained, yes, we know this is happening. The lock is closed, which is creating stagnant conditions. We have this really large bloom that we've detected by satellites in Lake Winnebago, and he very gently told me, like, well, you might be wrong, because he heard that there was construction in the area, a sewage pipe was left open, and there was sewage input to the lake, and just kind of ignoring the fact that there was a bloom visible from space just upstream of this site. So those thoughts about it's the nutrients and it's immediately preceding that bloom tend to be really strongly held by some people. So those strong assumptions that the nutrients and warm water temperatures are to blame for blooms can really make people sometimes disregard some of the physical aspects of bloom formation. In this photo, you see a floating scum in a jar test of planktonic cyanobacteria. That buoyancy of cyanobacteria allows them to accumulate as scums on the surface. And then, of course, if you have gentle winds, that can push them to the downwind shore. And here you've got a satellite image of a couple of lakes in the Madison area. It's really highly processed. And you can see that that happening here. We've got blooms that are being pushed from winds from the southwest. We can have pea soup conditions at that downwind shore, while the upwind shore can have perfectly clear water. This is actually Cladophora sitting on the bottom. So people don't always think about the wind and calm conditions as a reason for why they might be seeing bloom in that particular area. Sometimes they think it's just that really localized nutrient input, when in fact wind is moving cyanobacteria from elsewhere in the lake to that downwind shore. And morphology of the shoreline can affect bloom accumulation too. So my apologies to people from Illinois and Michigan. I developed this for a talk in Wisconsin and used these out of state examples. So people don't always think about how the shoreline morphologies with bloom and buoyancy of blooms can work to trap blooms and other aquatic debris. So here you've got some channelized systems that are allowing property owners here to have lake access. Here is a really artificially shaped system with this sort of dogleg here on this lake in Michigan. And if those channels are facing into the prevailing winds, those are really good traps for blooms to be blown in. And then unless you get wind in the perfect condition, those blooms are going to stay there. I do get complaints about blooms accumulating in access channels similar to this in Wisconsin, and they can be really significant issues for homeowners. It can require interventions like dredging, circulators, et cetera, to move those blooms out and mitigate them. So unfortunately, this is an example of some really highly engineered systems that are inadvertently designed to trap cyanobacterial blooms. So the other things that people think about as bloom causes heat, but blooms also like it cold. And this is actually a stolen title from Dr. Kate Reynolds' recent paper with others in Limnology and Oceanography Letters. Ted Harris did the Current 93 webinar recently, a look beyond nutrients, that covers some of the things in this paper. He's one of the co-authors. So it can be really perplexing for people to see blooms in late fall to winter. And actually, late fall blooms are really not uncommon. If you think about what happens with lake turnover, you get that boost of nutrients being brought up from the bottom, being mixed into the lake water. And of course, water cools down more slowly than the air tends to cool in the fall. So you can still have conditions that are conducive to blooms with that little extra boost of nutrients. And these photos are from Devil's Lake State Park in Wisconsin. There was a bloom in 2020 near the end of November into December. On the left is this photo. You can see those glass calm conditions that are allowing buoyant cyanobacteria to form that floating scum. And we had a researcher go out and collect a sample. And this is not foam. This is actually ice on the shoreline on the right-hand photo. So yeah, you can have blooms when you've even got ice on shore and it's really cold out. And of course, there can also be blooms in the winter as well. These photos on the right are of a Planktothrix rubescens bloom in a lake in Polk County, Wisconsin. This is the Planktothrix under the ice. Really nice clear ice. We worked with county staff to actually put a caution sign up at that lake because it's a really popular ice fishing lake, and we just wanted people to be aware of what they were seeing and take appropriate precautions when they were seeing this reddish purple stuff pop up in their ice fishing holes. And this is what Planktothrix rubescens looks like under the microscope. So how people think about water bodies can kind of impact what their expectations are as well. So when you think about a lake, you probably picture something that looks like this with kind of clear water, and people have that expectation. However, we have a lot of reservoirs and another type of reservoir called flowages in Wisconsin, especially northern Wisconsin. And unfortunately, they can be more susceptible to blooms than natural lakes. And this is for several different reasons. So I can't claim credit for this idea about logging practices. So Dr. Gretchen Garish, who is the director of the UW Center for Limnology's Trout Lake Station, presented a seminar earlier this year where she was looking at impacts of past logging practices on manumin or wild rice populations in Wisconsin. And a lot of the reservoirs and impoundments in northern Wisconsin started being built in the 1860s to support moving logs downstream to where they were being milled, and were also water bodies were also dammed to create hydropower to run sawmills and other mills. And a lot of that reservoir development happened into the 1950s. So what happened in the 1800s, a lot of these impoundments were created to store water. And then in the spring, during high water conditions, those logs were released into large river systems for transport, along with those lakes, those impoundments. The dams were opened, and this obviously created a lot of scouring in these systems. A lot of sediments probably were unleashed, and I think a lot of the things that were impacting wild rice growth are also impacting blooms. You have sediment input, you've got these impoundments, and those are things that can really help to support bloom growth in a lot of these impoundments on large river systems in northern Wisconsin. Reservoirs and impoundments continued to be built in Wisconsin into the 1950s for both hydropower and also for hydrological storage, especially in the Wisconsin River system, to help regulate flows for electricity generation downstream. And this is an image from US EPA Cyan, which is a tool to use remote sensing to detect harmful algal blooms from space. And what I want to point out is, so the redder the water body, the higher the bloom concentration in it. And we do have a lot of these large reservoirs in northern Wisconsin that are showing up as red. So these are really susceptible. Here, this is the Big O Plain Reservoir in central Wisconsin, Petenwall and Castle Rock on the Wisconsin River, and you were seeing these showing up as having blooms. So a lot of these reservoirs are parts of large river systems. You've got huge watersheds upstream. You have a lot of legacy nutrients and sediments in those. And in the case of the Chetek Shane here, those water bodies tend to be very shallow, about 5 to 7 feet average depth, so they can warm up really rapidly too. And unfortunately, those are things that can support blooms, but people don't always think about these water bodies in northern Wisconsin as being reservoirs and having these susceptibilities for blooms. So these are just some of the perceptions that I've encountered in working with the public. I'm addressing these in some of our outreach materials to hopefully better educate the public about the blooms. So I hope this is useful to you as well. And I'm going to give a couple of quick shameless plugs. So first of all, the Interstate Technology and Resource Regulatory Council, or ITRC, developed a couple of guidance documents and resources on planktonic and benthic harmful cyanobacterial blooms, or HCBs. I worked on this project. They're really useful for giving you background on cyanobacterial blooms, info on toxins, monitoring, communication, and response planning. There are interactive tools, a visual guide and identification video. And what I find really useful in working with lake groups are their standalone fact sheets for a number of management technologies for cyanobacterial blooms, using reviewing peer-reviewed science on those. So really useful. I will put those links in the chat when I'm done. And also the Great Lakes HAB Collaborative has an upcoming webinar series. I am a co-chair of the steering community, and next January, you're going to have a lot of opportunities for learning more about HAB research. The HABs Collaborative is hosting a webinar series in the 2 weeks that follows the Algal Bloom Action Team's 4th annual Harmful Algal Bloom Virtual Research Symposium, which is on January 4th and 5th. So the HAB Collaborative's webinars on the 11th and 18th of January. There are going to be 3 speakers each day, and you can either use that link to register that you see there on the slide, or I'm going to put that in the chat as well. So that's all I've got for now. Thank you for tuning in.
Okay. Thank you, Gina. I appreciate a little bit of sharing from your perspective on some of those perceptions and sharing those tools. And thanks for sharing a little bit of the other parts of the harmful algal bloom, I think, network that operates in this space. And so, yes, looking forward to seeing some of your links or tools posted, and we'll be sharing more about that virtual symposium at then as well. So I think what I'll do now is I am going to reshare my screen and introduce our second speaker. So our second speaker is Dr. Anna Boegehold, who works at the Cooperative Institute for Great Lakes Research, studying seasonal patterns in the ecology and toxins of harmful algal blooms. Anna uses historical and novel data sets to examine short-term environmental and physiological changes that can potentially impact the long-term trajectory of a bloom. Anna has a background in aquatic ecology and ecotoxicology, and has interdisciplinary experience working with cyanobacteria and HABs. She's also interested in science communication and strives to connect her work with communities who are impacted by HABs and other environmental issues. And so I'm pleased to bring Anna on board to share a little bit of some of the water quality monitoring data from both NOAA GLERL and CIGLR. So I will stop sharing, and Anna, ask you to share and turn it over to you.
Cool, thank you so much, Chad. Let me share this and okay, I should be good, correct? Yep. Okay.
Yep, looks good.
So yeah, thank you everyone for being here. Thank you, Gina, for your talk. I want to say that up top, my objective of this presentation today is to introduce everyone in the audience to a really amazing and very public data set from Western Lake Erie water quality monitoring, because I think this is a great resource and it's available to anyone. So I'm going to talk about this. But first, I just want to say hi to my mom, who's in the audience, and I think my brother is too, and I see some other familiar names. My mom is legally blind, so I will be describing some of the pictures on the screen to help her, and if there's any other visually impaired folks in the audience as well. But yeah, also first, I'm going to unravel some of this alphabet soup in my title. I work at CIGLR, which is the Cooperative Institute for Great Lakes Research. And CIGLR is a cooperative institute. It's one of many cooperative institutes by NOAA, and then they have a host institution. And for CIGLR, it's the University of Michigan in the School for Environment and Sustainability. And when I say GLERL, that is the Great Lakes Environmental Research Lab that NOAA has in Ann Arbor, just south of U of M's campus. And that's where CIGLR is, that's where we're physically hosted. So most of us work in this building in Ann Arbor, and we also share it with folks from NOAA. We have some Coast Guard folks in there, Sea Grant, we have some Sea Grant people, GLOS, the Great Lakes Observing System, is there as well. So hopefully that decodes a little bit of that organization for everybody. So yeah, now I'm going to talk about this data set and its history and where it started and what's available in it. And if I had a lot of time, I would start all the way back during European settlement, when a lot of the coastal wetlands were drained in the Great Lakes region and Lake Erie in particular, because in my opinion, that's where these HABs issues really started. But for the sake of this talk, I'm going to fast forward to the 1960s. This was kind of the decade of environmentalism in America, and there was a lot of environmental atrocities happening during this period of time. Lake Erie was just plagued with HABs in the 60s, and in the 70s, the Great Lakes Water Quality Agreement and the Clean Water Act were put into place because of concerns of all of these different environmental nuisances, such as harmful algal blooms, or HABs. So these acts were signed, and they really focused on reducing nutrient input into the lakes, kind of like what Gina was talking about, back then. One of the prevailing thoughts was we have all these point sources, meaning like one single pipe, you can see it going into the lake. That pipe is carrying too much resources. We got to stop those pipes. And that worked for a little bit. The Clean Water Act regulated how much nutrients like phosphorus could be deposited into a lake from like wastewater treatment plants and different industries. And that really did help to reduce total phosphorus in Lake Erie for a bit. And in the 80s through the mid 90s, Lake Erie was considered restored. But then in the mid 1990s, the HABs came back, even though the regulations in place from the Clean Water Act were still there. And the total phosphorus in the lake hadn't really increased much. It's been pretty steady. So, this is a little confusing to why are we having these HABs back? They were gone for a while. But it was a important enough problem that Congress signed the Harmful Algal Bloom and Hypoxia Research Control Act, or HABARCA, in 1998. And that was a really landmark law to be signed, because that is what mandated NOAA to advance the scientific understanding and ability to detect, monitor, assess, and predict HAB and hypoxia events. And I just realized I forgot to describe one of the pictures on my earlier slides. Sorry, Mom. On the History of Lake Erie slide, I have this really amazing picture. It looks like it's taken from a drone looking over just like a green pea soup of a lake with a teeny tiny speedboat driving through this Cyanobacterial bloom, and you can see the wake lines from the boat, and it just provides kind of a depiction of how extensive spatially these HABs can be. So anyway, we're at HABARCA in 1998. And so now NOAA has to detect, monitor, assess, and predict HABs and hypoxia events. And so some of these products that were created as a result of this, you might be familiar with. I think I saw Rick Stumpf is here from NOAA NCOS, which is the National Center for Coastal Ocean Science. And he is one of the people whose names you might see on the Lake Erie Harmful Algal Bloom forecast that comes out every year. So some of the products that were created to serve the purpose of HABARCA were satellite imagery, models to do short-term predictions on where the bloom was going to be how severe it's going to be that year. If you go to did I have any pictures on there? Oh yeah, sorry again. I have on the left side of this screen, I have a satellite picture of Lake Erie, and you can see in the western basin, there's just a big blob of green bloom kind of extending into the central basin to the east. And on the right, I have a screenshot of one of the Lake Erie harmful bloom forecasts from the 2022 season, which has a little descriptor of how severe the bloom is predicted to be that year and why. And then there's some other satellite images as well that shows the current state of the bloom. There's other products too. If you go to the NCOS HAB forecast for Lake Erie website during the season, which I didn't, and that's why there's nothing really colorful on these pictures here. But what I have on screen is a screenshot of the landing page for the NCOS's Lake Erie HABs forecast, where you can they have 3 different products that you can go look at. They have what the current observed bloom position is from satellite images. They model forecasted bloom position. And then as Gina was talking about, HABs can be buoyant and move vertically throughout the water column, which is an important thing for drinking water managers to consider. And so there's also a vertical mixing forecast. And these are super great tools, but they all need in situ, on the ground, in the lake, sampling to support them. We need, samples to verify what the satellites are seeing and make the connection between the satellite image and what's happening in the lake. People like Rick, who do modeling and forecasting, need historical conditions to be able to predict future conditions. Folks at CIGLR, which was CIGLR back then, and GLERL started getting out and taking these in situ water sampling. I have 3 images here of just people sampling throughout the entirety of the program. There's on the left panel, someone is dunking a Niskin into the water, which is what we use to collect subsurface water samples. The middle, someone is deploying, it looks like some type of sensor that I don't know what that was for. Sometimes we do a lot of experimental stuff, but someone's deploying that over the boat. And in the far right image, I have a lab analyst who's filtering some water, because after we sample the lake, we have to go back to the lab and filter and prepare the samples before they're even analyzed. So just wanted to show all of the work that people have done over the years. What do we look at when we sample for water quality? What types of measurements are needed to support the forecasting and support these other modeling and forecasting products? We collect nutrient fractions, phosphorus and nitrogen being the main 2 that we look for. We collect pigments such as chlorophyll A and phycocyanin. And phycocyanin is a pigment that is unique to cyanobacteria. We collect microcystin data, of course. Microcystins are one of the toxins. It's a hepatotoxin, so it affects your liver, and that is produced by the microcystis blooms that happen in Lake Erie. We look at optical properties to, again, help just calibrate the satellite images and make sure that, what we see in the satellite, we can accurately read in terms of what's happening in the lake. And we've had a bunch of water quality parameters that have been added and removed over the years based on what our current research needs are and what's available. So this is this water quality sampling began as just kind of nebulous, like dynamic way to verify models and satellite images. Oh, and in this slide, I have an image of someone in a fume hood who's analyzing one of our pigment samples. They have to be analyzed in green or low light so they don't like influence the sample reading. So yeah, this whole water quality monitoring program, it didn't start as a long-term program, but it kind of ended up turning into one just by, you know, research needs kept it going. And then in, I think, 2012, the GLRI, or the Great Lakes Restoration Initiative funds, became available, and those were used to keep this program funding and running and expanding to fit our ever-growing needs. So yeah, I have a few pictures here, again, of people either sampling HABs on the Great Lakes, on the two end pictures, and the photo in the middle is Tom Johengen, who just retired as the director of Sea Grant, using a fluoroprobe or CTD in the lab. So yeah, again, this program started out of a need to support other products and then kind of became its own thing in a way. And on this slide, I have a map of Western Lake Erie Basin that we sample from. We have to sample on the US side of the water because, you know, we're federal, NOAA is a federal agency, and some of these sites have come and gone over the years, again, depending on what research needs were. For example, sites 2, 4, 6, and 8, those 4 have been sampled for the entirety of the sampling program, but others like WE12 and WE14, those were added in later as needed. And the goal for choosing these sites, well, at first, these sites were chosen based on providing a good assessment of the spatial extent of the bloom in US waters. So that's kind of how these sites came about. I want to point out a couple of the locations of importance. We have sites WE9 and WE6 in the Maumee Bay part of the Western Basin. This is where the Maumee River flows into Western Lake Erie, and the Maumee River is highly agricultural and then urban watershed. And the Maumee River is, you know, often cited as being responsible for the high nutrient concentrations that get pumped into Lake Erie. So WE9 and WE6 are 2 sites to kind of capture, you know, where the intense nutrient concentrations are coming into the lake. WE4, for example, it's kind of in the, you know, middle of the Western Basin. If you go north from WE4, you'll start to hit the Detroit River channel. And the Detroit River is important to the dynamics of Western Lake Erie because it carries most of the hydraulic input. So most of the water coming into Lake Erie is going to come from the Detroit River. The Detroit River also carries a lot of nutrients into Lake Erie, but it has such a high flow that they're diluted more than the Maumee River. So we want to see, you know, we want to look at all of these dynamics. How is the Maumee River influencing the bloom? How is the Detroit River influencing the bloom? Like Gina mentioned, there's wind and wave action that can push the bloom against the coastlines. So, you know, these sites in our program was really designed to try and capture the interseasonal variability and also the intraannual variability and the spatial variability of the bloom. And on this graph, on this page, I have an image of a graph that shows all of the stations that we've sampled throughout from 2012 to 2021. And each line, so each graph panel is a different site, and each horizontal line on the graph has dots corresponding to months on the x-axis, and each dot is a sampling point. So all of these dots are all of the times that people have gone out between 2012 and 2021 with our organization to collect these water quality samples from Western Lake Erie. And let me just tell you how big and how awesome of an effort this was, and it continues to be. So the data set from 2012 through 2021 of our water quality data has about 2,000 rows of data. And if you do modeling, like, this isn't a lot really, but think about that every single one of these data points, someone had to wake up super early in the morning, get to GLERL before the sun rises, pack up the van, go down to the Toledo Beach Marina by Monroe, get on a boat, take that boat out, physically collect the samples, go back to the lab. Then those samples had to be immediately filtered and processed and preserved and stored, where they are later analyzed by someone to get the actual data. That data then goes through quality analysis and quality control. And then finally, that data ends up in the database. So a lot of people and a lot of work have gone into providing this really amazing resource, which is why I want to tell you all about it, so you can access it and access this data. So yeah, like I said, the water quality monitoring program started after Habarka. So it started in the early 2000s, but the program really became an established entity with some regularity in 2012. So that's why we start our data set there. And a couple places that you can go find this data is, number one, on GLERL's website. We put up our weekly data. We have to report a certain number of the parameters within a couple days, so that we can, number one, update the modeling forecasts, and number two, we also provide real-time, up-to-date seasonal bloom information on the website. So you can go to glrl.noaa.gov/res/HABs and hypoxia/WE weekly current, and you can see what the seasonal water quality of that year's bloom in Lake Erie looks like in near real time. So this is one way that you can access the data, but the problem with this is the data from previous years isn't stored here. This is a very temporal space to get data if you need it right away. Also, in the past, one way that you could access this data set was from an informal data share. You really just had to know who to email, and then they would email you back. But that's not really accessible for the public like this data should be, right? So in 2019, Lacey Mason from NOAA and Ashley Bertner, who is a CIGLR, she's been in CIGLR for a while, put all of the data from, starting at 2012 together and permanently archived it in NOAA's data repository. So now all of our data is going to be permanently stored at this one site, and we can update it when we get more data. So this is where the database is held. I have some links and QR codes on these pages that will link to the data set if you need to take a screenshot or something. I'll also share some information at the end of the slide, and you can always email me too. But so putting all of this data into an archive was a really big move for this water quality monitoring program, because now it's just a little bit easier for anyone to get this data. And so what I did when I first joined CIGLR in 2022 was, okay, we have this great program, we have this great data set, the data is archived, but we needed to archive all of the metadata permanently. So we wrote a data description paper where you can find detailed sampling and analytical methods for how we got all of this data. There are directions to access the data set. There's a statistical summary of the data set. And this data description paper is a living paper, so we can update that as the data archive is updated as well. And hopefully having this paper out will improve accessibility and use of this fantastic public data set. I know I need to hurry up, so I'm going to wrap up so we can get to questions. But I just wanted to show just a little example of what you can find in this paper. Again, I have a link here and the QR code, and I can post those in the chat afterwards. But I wanted to just show everyone, we're working on going back and doing some, analyses now, but I just want to show what the data set has in it. So I chose two sites to show. WE6 is on the left panel, WE4 is on the right. WE6 was that Maumee Bay site. WE4 is out in the middle, gets a lot of input from the Detroit River. And you can just see how spatially different these are. WE6 has a lot more chlorophyll and phycocyanin and toxins than we find at WE4, just because of its proximity to the Maumee River. There's, you can also see how things change over time in this data set as you move from 2012 to 21, and you can look at anomalous years. Like 2015 was a really big bloom, and we can see that WE4 had way more chlorophyll in 2015 than it had other times. There's another chart that looks at, just shows you the same thing, but with different parameters. And I just want to conclude that this data set is really cool and you should use it. You can find, there are official citations for both the data set and the metadata. So it should be very, useful if you're a researcher. We have the real-time updates on the website during the season. And we're going to continue to update the data set and the data description paper as we add more really great tools for assessing the water quality and how it connects to harmful algal blooms in Western Lake Erie. We're going to include genomic information, more carbon fractions, more toxins and congeners. So stay tuned, because this data set's about to be elevated. And I also just want to mention, we have Saginaw Bay data too that no one ever uses. So I just, really wanted to bring attention to these wonderful data sets for everyone to hopefully use. And yeah, I put my email here. It's annanboeg@umich.edu. This is a DOI to the paper, so you can start using these really cool resources. And of course, please just send me an email if you have any questions or need help finding it, because this is public data. This data is collected with, federal funding. So this is your data. This data belongs to everyone, and I want it to be accessible, and I want it to be useful for whoever wants to use it to hopefully, improve water quality in the Great Lakes. So that's all I got. Back to you, Chad.
Okay, thanks, Anna. Thanks for sharing that with us. And I'm going to ask Gina to unmute and bring you back to the front. and we'll do some questions and answers. We do have some questions in the chat. And so, so I'm just trying to make sure I'm getting everyone viewed correctly. All right. So, yeah, we have had a number of questions come in. So I think I'll start, Anna, with one for you. There's a question on like, what optical properties are you monitoring? Are there particular wavelengths, anything that's akin to specific UV absorption?
We have, sorry, I'm trying to, okay, I just posted the link in the chat to the article, the data description paper, which tells you literally everything you want to know about this data set, and it's open source, so anyone should be able to access it. We collect, this is a complicated question. Okay, so for this one particular Western Lake Erie weekly monitoring cruise that we do, we use a CTD instrument, and that collects stuff such as PAR, photosynthetically active radiation. And then we have a couple different like light attenuation. So just some very basic light optical properties with that data set. But we are also working on some other projects where we're trying to get even more descriptive like inherent optical properties from the near shore areas that get a lot of sedimentation kicking up, to try and more accurately be able to, tell by satellite what's happening there too. And again, whoever asked that question, literally send me an email and we can talk more if that's useful for you.
Okay, thank you. Gina, there was a couple of questions came in for you early on. First one, can algae and cyanobacteria live in the same environment together, or is one of them will be dominant and kill the other?
Yeah, you certainly do have mixed assemblages in any water body. It's usually those situations where you've got high nutrients and other conditions that really are more optimal growing conditions for cyanobacteria when you see those populations really start to dominate. And it's really more of them outcompeting the other algae.
And I think the second question was a little bit of allusion to, not all cyanobacteria are toxic, and trying to understand a little bit about, it's to some extent, I think it's a risk, and like, how concerned should people be, or what percentage of algae and cyanobacteria are really toxic?
That's a good question, and it's pretty challenging to answer because while not all cyanobacteria can make toxins, some can, but even of those that can, they don't make them all the time. They have to have the right conditions that induce them to producing toxins. In many cases, the toxin molecules themselves are sort of expensive things for them to make. So there have to be certain conditions that we don't completely understand yet that can induce toxin production. So usually the guidance for people recreating around water is, well, if you've got any doubt about what you're seeing, stay out. I would add to that, anytime you see water that looks really green or other unusual colors, or you see other unusual accumulations, even along the shoreline, that's when you have to be wary. But be especially careful with dogs. We've had a number of dog deaths nationally where dogs go into water that may look clear, but there are benthic cyanobacteria which grow on the bottom of systems. They can sometimes float up to the surface, and if dogs ingest them, and if those benthic cyanobacteria are making toxins, unfortunately, sometimes the dogs die. So be careful around anything. If you don't exactly know what it is, keeping it out of your mouth or your dog's mouth are really important.
Yeah, I want to add to that is also a great question, and one that we're still kind of, teasing out the details of. I mentioned that, our water quality monitoring program is ever evolving as new needs come up, and that is one of them. We want to look at genomic information to see, what percentage of genes in in this bloom can produce microcystins, and comparing that with the actual toxin data that we get. And yeah, great question, and it's still being answered.
Yeah, and I think the next question I think has a bit of challenge in terms of Anna, you talked a little bit about some of the history of the algal blooms in Lake Erie, and the questions around some of the shifts that we've seen in species as we've gone from the 70s to the 90s, and how that's changed in Sandusky Bay and other places where we've just seen this shift in the species that we see present. Can you talk a little bit about that?
Yeah, so what we see in the blooms that we experience currently, it's dominated by microcystis in in the good times, when it's nice and hot and calm and there's good nutrients. And then we do see, in the past couple of years, we have been seeing a shift. I notice it kind of when it starts, you feel those winds that bring in the fall weather. The water temperature and air temperature get a little colder, nutrients are kind of depleted, we might get a little bit more turbidity, and then we see the bloom shifting to another species, Dolichospermum. And some of this, again, I don't know all the answers to this, but a couple things that would cause a species shift, like cyanobacteria, like Dolichospermum, and others can, it's called fixing their own nitrogen. So they're able to trap nitrogen in a way that's usable to them really easily. Microcystis can't do that. So, Dolichospermum is kind of a sign that maybe the nitrogen levels are, going down, and it's not appropriate for microcystis anymore. But yeah, there are a lot of questions, and I know, so, and talking about what species dominance we had in the 60s and 70s, I'm not 100% sure on that, but I am pretty sure that I know people are working on sediment coring to try and kind of determine some of that data that we wish we could have gotten back in the 60s and 70s, but didn't. So yeah, another interesting question with just a lot more. We have a lot more to go to be able to tell that full story.
I think, Gina, maybe I'll toss this one to you first. But you mentioned some of the cold, some of the blooms that we see that are not tied to some of the hot weather that we typically see in summer, but more in the fall and even into early winter. And any idea of research that's been done then to figure out how those late season or cold blooms are impacting fish, and is that different than what the impacts may be when we see some of the more hot weather blooms?
Yeah, that's a good question. I don't know of any research looking into this. Just my sense from the blooms that I've had reported to me, those later season blooms, they don't tend to be as big. So you're not having those issues with, say, oxygen depletion that you would see normally in summer months. And that might be because colder water holds more oxygen than warm water. So you don't have those stresses on fish populations that you would normally have in summer months.
And anything you want to add on that?
No.
Okay. Anna, can you discuss the role, you talked about Maumee River and kind of that as maybe one of the drivers of some blooms, and it still is a source of dissolved reactive phosphorus, and that delivery coming in through the system for the blooms.
Yeah, so both Lake Erie and the Maumee River are named after tribes that were inhabiting these places when settlers arrived, which I think is really interesting because people have been using these systems for as long as people have been around in Lake Erie. And The way we use these systems today is the Maumee River is very, the watershed has a lot of agriculture around it. And yes, I think I mentioned the total phosphorus numbers have pretty much stayed steady, but the type of phosphorus that's bioavailable to the algae, the like soluble phosphorus, seems to be going up. It has, gone up a little bit since the 60s and 70s, and that's thought to be from the agricultural practices. So yes, we are having like shifts in like what we call the phosphorus and like nutrient fractions coming into the lake than we did in the 60s and 70s. Is that kind of it? Okay.
Yeah, thank you. All right, I think we're going to need to wrap up as we are just at our time. And I wanted to thank both of you for coming on and to be with us today to share some of your expertise and knowledge around harmful algal blooms. For those that asked questions that we didn't get to, I apologize for that we just didn't get quite enough time to be able to ask all those questions. I did want to just share a slide quickly that has both contact information for Gina and Anna, and maybe Gina and Anna, could you both put emails into the chat while I'm kind of wrapping up here? But again, it's I think both Gina and Anna have said, don't hesitate to reach out if you've got questions that have come from their presentations today. I also wanted to just quickly make a plug. Gina mentioned this earlier, but the Algal Bloom Action Team will be hosting their 4th annual virtual research symposium, and that's on January 4th and 5th. And I know that I think the call for abstracts is still open. So if you have a great idea for a paper or a presentation you'd like to present, get a proposal in for us. We will be within the next couple of weeks here finalizing the agenda and sending out more details on the timing and registration for that event. And it was great to see, Gina, that there was a couple of webinars following up over the next couple of weeks after that. So it's going to be a great early 2024 slug of harmful algal bloom information that I hope you're all willing and able to take advantage of coming up in 2024. So Anna, again, Gina, again, thank you so much for joining us. Thank you all of you that joined us today as well. We hope you have a great day and hopefully have a great rest of December as we quickly end 2023 and move into 2024. So thank you again.